pre-calculus students. Welcome to section 7.5, the last section we're going to look at in chapter 7, systems of inequalities. So we're looking at these because most relationships in the world are unequal, right? We always set everything equal to each other and solve for that. But truly, most things are unequal. In a lot of things, we want them to be unequal, right? For instance, in our sports, right? We don't really want the scores to be equal. We want our score to be greater than someone else's. And you may have already found, if you're working, that your paycheck is always less than you think it's going to be. And that is true with our savings accounts too. It always seems to be less than you think you're going to be, and credit cards are always more than you think. So anyway, we have a lot of inequalities in our world, and so we're going to look at those today. So the steps to graphing and solving is first we're going to sketch the equations themselves. So if you have a less than or equal to or greater than or equal to, we are going to use a solid line for our equations, and that means that the points that lie on that line also make the inequality true. If we have a less than or greater than, we are going to be using a dashed line, and that means that that line or curve is our boundary, but the points on that line or curve are not included in the solution. If we have greater than or equal to or greater than, we are going to shade above the line or curve, or we're going to shade outside the curve. If we have less than or equal to or less than, that means we will be shading below the line or curve, or be shading on the inside if it were something like a circle. Okay. So then we'll find the solution region where the shading of all the inequalities occur. So if you have two inequalities, your solution region is where you have double shading. If you have three inequalities, your solution region lies where triple shading is. And if that does not occur, if there's no region with double shading or triple shading, then there's no solution. And if we've been given a sketch, like on number 62, we're going to write the inequalities using A and B above. So let's take a look at number 18. We're going to sketch the graph of x minus 1 squared plus y minus 4 squared is greater than 9. Okay, so what we're first going to do is graph the sketch of x minus 1 squared plus y minus 4 squared is equal to 9. Notice this is a circle with a center at 1, 4 and a radius of 3. Okay. So let's make that center point. Here's 1 and 1, 2, 3, 4. And we're going to make a radius of 3. We're going to pause for just a moment. Just checking on my brother. He thought something cool was happening. So we have a center of 1, 4 and a radius of 3. So to help myself, I'm going to go 1, 2, 3. 1, 2, 3. Right, left, right, up and down. So I can make the best circle possible. There we go. Now I'm about to draw the circle. Notice because there is not a solid line underneath the greater than, that I will make this a dashed circle, meaning that, and this is supposed to be a circle, but you know my drawing, kids, right? Meaning that the points on the circle do not make the inequality true. Now, because they are looking for all the XY points greater than 9, which means greater than a radius of 3 squared, we are going to shade on the outside. All of these XY points, if you put them into the inequality, would make it true. All these XY points would be, from this point, a radius greater than 3. Okay, how about number 52? We're going to sketch and find the vertices of. So we have a little system here. Notice that our first inequality is a circle with center at 0, 0 and a radius of 5, right? So let's go ahead and sketch that. Okay, 0, 0, radius of 5. Right? Notice because we have a solid line, I'm going to make my circle solid, meaning that the points on the circle do make the inequality true. And because it's less than, so I'm looking for all the XY points that would be less than with a radius of 5. So that would be on the inside, all these points here. Make this inequality true. Let's also graph 4x minus 3y is less than or equal to 0. This is obviously the equation of a line. So what I'm going to do is write the equation of that line. Let's see, I'm going to work to get the y alone, right? We're pretty good at that. So I'm going to subtract a 4x from both sides. And I have negative 3y is less than or equal to minus 4x. There we go, negative 3y and is less than or equal to a negative 4x. And I'm going to divide both sides by a negative 3. Remembering that when I have an inequality, if I multiply or divide both sides by a negative, I have to flip the sign. Okay, so I am going, for good reason. So I'm going to graph the line y is greater than or equal to 4/3 x. All right, so let's go ahead and let's start at 0, 0, right? And I'll do a slope of 4/3. So I will go right 3 up 4. There we go. Right, now let's go ahead and draw that line. Notice that it has a solid line, so I'm going to draw it with a solid line. There we go. And because it's all the y's greater than that line, I'm going to shade above. So in blue. So the solution region is this entire set of points here where there's blue and there is black shading. Okay. They also asked us to find the vertices. That would be this point here of intersection and this point here of intersection. So what I'm going to do is I'm going to erase number 18 and come to the left and find the 2 points here where these two equations are equal to each other. It does look to me like it is actually the 0.34, right? And negative 4, 3, negative 3. It's hard to tell with my drawing, which is why we use algebra. But we can take a pretty good guess at it. But let's go ahead and solve. All right, so here's what I'm going to do. I have x squared plus y squared equals 25, right? I'm trying to find where these 2 points lie on both of these equations, and that's where x squared plus y squared equals 25 and where y is equal to 4/3 x. Right, so we're trying to find those points there. Okay, so I think I'll do a substitution here. Right here, y is equal to 4/3 x. I'm going to pop that in for y, and I have x squared plus, and when I square, I'll get 16/9 x squared equals 25. There we go. A couple ways to go. We can collect our like terms here. I'm going to call this x squared 9/9. And when I add up these x squareds, I have 25 of them. Okay. I'll multiply both sides by 9/25 to get the x squared alone. Again, a few different ways you can do that. There we go. The 9's cancel the 25ths. And we get x squared equals 9. And when we take the square root, we get x equals plus or minus 3. Okay. So the 2 points of intersection, one x has a 3, one has a negative 3, right? And we can work that out. When you put a 3 in, The 3's cancel and you get a 4, which is the point we saw on the top right. When you put a -3 in, you get a -4, which was what I was trying to say. -3, -4. I wasn't sure if it was -4, -3. Anyway, so we found the solution region and we found the vertices. Okay, I'm going to pause. I'm going to get number 62 up here, and we're going to work on that last problem. Hi students, we're on to number 62. They have asked us to write the set of inequalities for this graph here. Notice what we have is 3 lines and they are enclosing a triangular region between them. So let's start with the purple line. That is the vertical line located at x equals 1. Notice it is solid. So we'll put x and we'll put a solid line. X equals 1. Right? And then you notice that the shading is to the right. These are all the x's greater than 1, right? So we will put a greater than sign. That would get us to shade to the left, to the right of the purple line. Okay, let's work on the blue line, right? So the blue line here, notice again that it is solid. So I'm going to have a solid line. Notice that its y-intercept is a -3. Right, and the slope of this line, let's see, if we go over 2 and up 3, it has a slope of 3/2, and notice that the shading, right, is above the line. So again, solid line, shading above, and that would cause us to shade above the line. Notice with the black line that it is dashed. So we will not have, with our inequality here, we will not have a solid line underneath. Let's take a look. Notice that this line has a y-intercept of 6 and a slope of, let's see, as we go down 1, 2, 3, 4, 5, 6, down 6, and right 2. So it has a slope of -3. There we go. Notice that the shading is below the line. So we will have less than without an equal to. There we go. Here is our set of inequalities that would make someone draw this region. Thank you so much and have a good day.